Our objective today is to be able to use exponents and to be able to simplify expressions with exponents. The standard is 6EE1, write and evaluate numerical expressions involving whole number exponents. There are 3 vocabulary words that go with this objective in this lesson. The first one is the word exponent. It tells you how many times a number or base is used as a factor. Our second vocabulary term we'll be using today is a base. When a number is written in exponential form, the number that is used as a factor is the base. The third vocabulary term today is a power. And for a power is a number that can be expressed using an exponent. If we take a look at the example that we have down here, the base number and the exponent together, that's what we call a power. The base number, 5, tells you what number is used as a factor. The 5 is the repeated factor, so that's your base number. The exponent, 4, tells you how many times that base number is used as a factor. You can see that 5 is used as a factor 4 times, so your exponent here is going to be 4. If we evaluate that power, 5 times 5 is 25, times 5 is 125, times 5 would be 625, would be the value of 5 to the power of 4. Alright, I'm going to have you guys on your own take a look at this table. Right, I have 4 times 4, and I want to write that using an exponent. I want to write the product as an exponent. 4 is our base number. It's being used as a factor 2 times, so we use 2 as an exponent. We would read that as 4 to the second power, or 4 to the power of 2. The value of 4 to the second power we find by taking 4 and multiplying it by 4. That's going to give us 16. If I'm using 6 as a factor 2 times, 6 is my base number. It's being used as a factor 2 times, so 6 to the power of 2, or 6 to the second power. We find the value for 6 to the second power by multiplying 6 times 6, and that's going to give me 36. Here, in example C, the base number is 10. It's being used as a factor 1, 2, 3 times, so 3 will be our exponent. If I evaluate or find the value of that expression, 10 times 10 is 100, times 10 would be 1,000. 100 times 100 times 100. If I'm writing that expression using an exponent, 100 is our base number, and it's being used as a factor 3 times. 100 times 100 times 100, 1 times 1 times 1 is 1, and there are 6 zeros, 2, 4, 6. So 1, 2, 3, 4, 5, and 6. And that's going to give me exactly 1 million if I find the value of 100 to the power of 3. In example E, 3 is our base number. It's being used as a factor 1, 2, 3, 4 times. So I'd read that as 3 to the 4th power, or 3 to the power of 4. To find the value, I would multiply 3 times 3 is 9, times 3 is 27, times 3 would be 81. In example F, 4 is my base number. 4 is being used as a factor 1, 2, 3, 4, 5 times, so my exponent here would be 5. If I evaluate that, 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1,024. And our last example, our base number is 2. 2 is being used as a factor 1, 2, 3, 4, 5, 6 times. So our exponent is going to be 6. And now if I evaluate that expression, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Alright, we continue down a bit. In your own words, describe what the two numbers in the expression 3 to the 5th power means. Alright, so I'd want you to think about it and give that a shot. Alright, I'll wait a moment. You can stop the video if you'd like and try it. But in your own words, something like this would do. The 3. What does the 3 mean in your own words? That is the factor. Right? That is the number being used as the factor. What does the 5 mean? The 5 is how many times? How many times? 3 is used as a factor. 3 is used as a factor. As a factor. Okay? If we continue down and look at this table, we have 10 to the first power, 10 to the second power. Obviously 1000 is 10 to the third power. If I want to use exponents to complete the table and then describe the pattern, we have 10 to the power of 4, 10 to the power of 5, and 10 to the power of 6. If I'm describing the pattern, right, when using, writing powers of 10, when writing powers of 10, the exponent is the same as the number of zeros, is the same as the number of zeros, as the number of zeros in the value. All right, so something like that would do for your explanation where you're asked to describe the pattern here. Just a review of our vocabulary up top, right? And the table gives us, right, some special powers, some special exponents. When I have 3 to the second power, that can also be called 3 squared. It can be called 3 to the second power or 3 to the power of 2. When I have 3 to the third power, it can be called 3 cubed. Right? That's a special power, a special name when we have a power of 3. But I can also read that as 3 to the third power or 3 to the power of 3. This would simply be 3 to the fourth or 3 to the power of 4 for that next example. Okay? If I'm writing each of these products as a power, right, I'd stop the video and try to do these on your own, right? But I'm going to go through each one of these. Your base number here is 4, and 4 is being used as an exponent 1, 2, 3, 4, 5 times. So this would be 4 to the 5th power, or 4 to the power of 5. In example B, your base number is 12. That's what's being used as a factor. 12 is being used as a factor 3 times. So I'd read this as 12 to the 3rd power, or 12 to the power of 3. Our examples down here, they're on your own problems. Your base number is 6, and 6 is being used as a factor 1, 2, 3, 4, 5. 6 times. So your exponent is also 6, because 6 is the factor, and 6 is being used as a factor 6 times. In example 2, 15 is your base number. 15 is being used as a factor 1, 2, 3, 4 times. So 15 is your base. Your exponent is 4 because 15 is being used as a factor 4 times. I would read that as 15 to the 4th power or 15 to the power of 4. When we find the value of each power, I always like for my students to write the power as a product of its factors. So 7 to the 2nd power, if I write the power as a product of its factors, I would write that as 7 is your base. It's being used as a factor 2 times, and that's going to be 49. If I'm evaluating the power of 5 to the 3rd power, 5 is your base number. It's being used as a factor 3 times. So I'm writing the power as a product of its factors. 5 times 5 is 25, times 5 would be 125. In class, we talked about the square of a whole number is a perfect square number. So I want you guys to make a list of perfect square numbers, and it would look something like this. Your first perfect square number you would find by taking 1 and multiplying by itself. So 1 times 1 is 1. 1 is your first perfect square number. Your second perfect square number you would find by taking 2 and using that as a factor 2 times or multiplying it by itself. 2 times 2 is 4. So 4 is your second perfect square number. Your third perfect square number is 9 because 9 is the product of 3 times 3. Your next perfect square number is 16 because it's the product of 4 times 4, a number times itself. Your next perfect square number would be 25, then 36, then 49, 64, 81, 100, 121, 144, 169 for 13 times 13. 14 times 14 is 196, and 15 times 15 is 225. You should probably know your first 15 perfect square numbers. That knowledge is going to come in handy very often throughout the year and throughout the remainder of your your math classes through high school. If I'm identifying perfect square numbers, I could simply use my list and I ask myself, is 64 a product of a number times itself? And I see 64 on my list, so I know it's a product of a number times itself. So this would be yes, right? It's the product of, right, 8 times 8. Is 20 the product of a number times itself? Well, I don't see 20 on my list of perfect square numbers, so the answer to that would be no. Okay, the on your own problems, you could try on your own. You could stop the video now and try them on your own, and then turn the video back on and see what each of your answers would be. But I'm going to do the problems here, so check your answers. For problem 3, 6 to the third power. Write the power as a product of its factors. 6 times 6 times 6. 6 times 6 is 36 times 6 would be 216. Problem 4, 9 to the second power. I write the power as a product of its factors. 9 times 9, which would be 81. Problem 5, 3 to the fourth power. I write the power as a product of its factors. 3 times 3 times 3 times 3. I evaluate. 3 times 3 is 9, times 3 is 27, times 3 would be 81. And for problem 6, we have 18 squared. So I write the power as a product of its factors, 18 times 18, and I believe that that's 324. Problem 7, determine whether a number is a perfect square. Is 25 the product of a number times itself? Right? The answer would be yes. Right? It's 5 times 5. For number 8, is 2 the product of a number times itself? The answer to that is no. Number 9, is 99 the product of a number times itself? The answer to that is no. 99 is 9 times 11, not the product of a number times itself. Problem 10, is 100 the product of a number times itself? The answer to that is yes. It is the product of 10 times 10. Okay. Down at the bottom, the area of a square is equal to its side length. The area is the number of square units contained inside of a figure. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 square units contained inside of this figure. I can find how many square units are contained inside of a square by taking 3 and multiplying it by 3. When it's a square, all sides are the same. So the length is going to be the same as its width. So I take the length and I square it. 3 times 3, it's going to give me 9 square units. Right? We continue. Real life application. Right? You can look at the top example, but we're going to do the on your own problem. right? It says, what is the area of the square traffic sign in square inches? And then what is that in square feet? Well, in square inches, we find area by taking the length of the side squared. That's the formula for the area of a square. Well, the length of the side is 24 inches. So I want to square 24 inches. 24 times 24 is how we would find the value of 24 squared inches. We want to try to find that area. And what is the product of 24 times 24? All right, so that's going to be 24 times 24, which is 576 square inches. And I write that as inches squared. That's your area in square inches. But they also ask, and I'll show this in red, what's the area in square feet? Well, how would we find the area in square feet? Well, the easiest way to do that would be to take the length of the side and write it in feet. 24 inches is equivalent to how many feet? Right, well, that's 2 feet. And this side would be 2 feet. So if I want the area of this square in square feet, I would take the area. It's going to be equal to the length of the side squared. Area is going to be equal to 2 squared, right, which is 2 times 2, which is 4. And that is 4 square feet for the area in square feet. All right, I think that is the end of the lesson today. All right, you guys practice, and thank you for listening in. All right.